The student will be able to use their knowledge of logarithmic properties in graphing in order to graph logarithmic functions. So you know properties of logs, you know how to solve the equations, you know how to go back and forth. And you also, yesterday we talked about graphing. We're going to put those things together and we're going to graph some different types of equations. So yesterday, if you looked at the equation, it was just like, it wouldn't have had this plus 2 on it, or it was just the basic log functions of x. Well, now we've got some other things happening in the equation, and we're going to see how that changes the graph around, okay? So we're going to go the same process as yesterday. We need to figure out, we need to change it to exponential form in order to graph. So let's go ahead and take this one and change it to, we have a base 3 to the y power equals x plus 2, okay? But we need to get x alone because we need to be able to put in a number for y, again, just like yesterday, and then just simplify it to come up with an x. So we're going to move this 2 over here. So we really have 3 to the y power minus 2 equals x. So this is the exponential equation we're going to use to find points on our logarithmic equation, okay? So again, just like yesterday, we've kind of switched the places of x's and y's. So we're going to come up with y values first. We're going to simplify, and that's going to give us the x values. So yesterday, most of you figured out that we're really just coming up with y values that will work for us. So it doesn't really matter. Oh, excuse me. You can pick different y values than the people of your table. You just need to be able to figure out a basic shape for this graph so you can connect it. So let's just start with 0 again. So if I have 3 to the 0 power minus 2. Well, 3 to the 0 power is 1, because anything to 0 is 1. Minus 2 is negative 1. Okay? Now let's go. So that is the ordered pair. So negative 1, 0. Okay, then let's pick y is 1. So if y is 1, let me plug it in. 3 to the first power minus 2. 3 to the first is 3. Minus 2 is positive 1. So 1, 1. Okay, now let's go with 2. So 3 squared minus 2. 3 squared is 9. 7. 1, 2, 3, 4, 5, 6, 7. It's going to be somewhere out here. I just barely ran out of room. Okay, so we've got a pretty good idea of how we're moving to the right, what our domain is doing as we move right. Let's figure out what happens if I go the other way. So let's say if I pick negative 1. So that's 1/3 minus 2. 1/3 minus 2 is like negative 1 1/3. And when you are trying to figure out how to simplify and you are getting your numbers in this situation and you're writing your x's, you need to write these x values in whatever form makes the most sense to you. If you like mixed numbers, use them. If you like just straight up decimals, use them. If you like improper fractions, that's fine. You just need to know where to put that on the graph. So if you understand where negative 1 1/3 is, then use the mixed number. Normally I still know mixed numbers, but in this case it works okay. So negative 1 and a little more, and then y is negative 1. So we're about here. Okay, let's go with negative 2. If I use negative 2, 3 to the negative second power is the same as 1/9. So that's the same as like negative 1 8/9. So almost negative 2. So we're at negative 1 8/9, negative 2. So almost negative 2. Okay, so we've got a pretty good idea that this is going this way. So here It's getting really close to -2, but it's not touching it. And this way it's going here. Okay, so when we talk about the domain, yesterday all of our domains stopped at 0 because we weren't doing anything else with the logs. We just had log of x. But here, really now my domain is going all the way to -2 but not touching it, and then infinity. My range is still going infinitely down and infinitely up, but the domain is at -2. So here's what I want you to notice. If you go back up to the original equation, this +2 inside the parentheses, if you remember when we talked about quadratic functions and how they move around the graph, and even exponential functions and how they move, whenever you had a number inside the parentheses, that moved your graph left or right. And it was always inside the parentheses is opposite what you think. So +2 is left 2. So if you compare this graph to the one you saw yesterday, it does move the graph left 2 spots. Okay? So just kind of something interesting to think about and notice. All right, next example. Y equals log base 1/4 of x minus 4. Now here's the difference. In this first one, x plus 2 is in parentheses, so they are all a part of the log. In this one, x minus 4 is not in parentheses, so the -4 is not a part of the log. So before I change this to exponential, I need to move that -4 out of the way. So I'm going to add 4. So y plus 4 equals log 1/4, or log base 1/4 of x. Now that I have the log by itself, now I can change it to exponential. So my base is 1/4. My exponent is y plus 4 equals x. All right, x is by itself, so we can go ahead and start picking some numbers for y. So let's just start. Now, we're going to be a little bit more specific. So if I have y plus 4 as my exponent, I'm not going to start with 0 because that's an exponent of 4, and that's a great number to use, but I'm going to start with -4 because I know that 1/4, so -4 plus 4 is going to give me 0, and that's 1. So I'm using 1, -4 is my first point. Okay, now let's go with -3. Let's just see what happens. So -3 plus 4 is 1 whole. So 1/4 to the first power is 1/4. So 1/4 -3. So 1/4 for x, -3 for y. All right, let's go -4. So if I use -4, oh, we already used -4. Sorry. Let's use -2. So if I use -2, that is -2 plus 4 is 2, and 1/4 squared is 1/16. So just barely over negative. So it looks like I'm getting really close to 0. So I can tell what we're doing on that side. Let's go the other way. So let's go with -5. So 1/4 to the -5 plus 4 is really 1/4 to the -1. If I have 1/4 to the -1, that's 4 whole. So it flips that fraction again and gives me 4 as a whole number. So 4. So 4, -5. So 4, -5. Okay. So then I could pick -6. And I would see that -6 plus 4 is -2. And remember, the negative is really going to make it so it's 4 now positive 2, 16. And I don't have room on my graph for 16, negative 6. But we're just going to keep going, right? So we can tell this graph is going to go this way. That's probably a little extreme. And then it's going to get really close to 0, but it's not going to touch it. So my domain gets really close to 0 and then goes to infinity. My range goes negative infinity down and positive infinity up. So what did this minus 4 do? It's not inside parentheses with the x. Instead, it's outside of the whole function. And what you should notice that it did is it moved my whole graph down 4 units. Now, when you move a logarithmic graph down, it doesn't really change the domain or the range, because the range will always be negative to positive infinity. So no matter how you move up or down, that range doesn't change. So we didn't change the domain this time because we only moved down. Remember, if it's inside the parentheses, that's when we moved it left or right. So this first one changed the domain. The second one did not, because it only moved down. All right, let's look at the last example. So log y equals log base 3 of x minus 4 plus 2. So we know that x minus 4 together is with the log. Now, let's just kind of think for a second. This minus 4 inside, we said inside the parentheses with the x is going to move us left or right, opposite what we think. So minus should move us right 4. So our logarithmic graph should look like it's moved over to the right. This number on the outside moves us up or down. So we should see a graph that moves right 4 than we're used to and up 2 more than we're used to. That's the outcome we should see at the end. Well, let's make sure that's what we get. So before I can change this to exponential, I need to move the 2 over. So y minus 2 equals log base 3 of x minus 4. Okay, now we're going to change it to exponential. So the base is 3. The exponent, y minus 2, equals x minus 4. Well, before I can substitute numbers in, I need to get the x by itself, so add 4. So 3 to the y minus 2 power plus 4 equals x. Okay, so again, we're going to be kind of specific in the y values that we pick. So let's pick a y value of, let's start with 2. So I have 3 to the 2 minus 2 plus 4. 2 minus 2 is 0, so 3 to the 0 plus 4 is really 3 to the 0 is 1 whole. So that's 5. So I have a 0.52. So x is 5, y is 2. Okay, now let's see what happens when we use three. 3 minus 2 is 1. 3 to the first power is 3. 3 plus 5 is 7. So we've got 7, 3. Okay, so 3, 4, 5, 6, 7. It's going to be right about here. Okay, now, what if we picked 4? 4 minus 2 is 2. 3 squared is 9. 9 plus 4 is 13. So before I go up anymore, I'm going to end up way out at x is 13, and I didn't make my graph big enough for that. But we can get a pretty good idea. It kind of levels out. So now we're like all the way over here-ish, okay? Okay, now let's go the other direction. So let's go with 1. All right, so, whoops. Okay, if I have 3 to the 1 minus 2, it's negative 1. That's 1/3 plus 4. So I have 4 1/3. So 4 whole and a little more. Now, when I did the worksheet today, some of those, it was easier for me to change to decimals instead of keeping mixed numbers. So again, it's kind of personal preference. So I've got 4 1/3, a little more, and y is 1. Okay, let's go with 0. So 0 minus 2 is -2. 3 to the -2 is like 1/9. So I've got 4 1/9. 0. So 4 and barely anymore, 0. Okay. If we used -1, oops. Now I've got 3 to the -3. That's 1/27th. So 4 and 1/27th is still just closer to 4. So I'm going, -1, sorry. I'm going just barely past 4. So 4 and barely anymore, -1. So it looks like I'm getting infinitely close to 4 without touching it. And then I'm going out this way, okay? So my domain doesn't touch 4, but that's as far as it goes on the left, and it goes to infinity on the right. The range is still negative to positive infinity. So let's look at what we thought would happen. We thought this graph would move down 2. Up 2. We thought it would move up 2, and it looks to me like it did. So think about all the graphs you had yesterday. This graph is a little bit higher. Then we also said it should move right 4, and that's very obvious because 4 has become the new like asymptote spot. It's not going to pass it, and we were used to that being at 0. So just some interesting situations. You can always create a table to figure out where to plot your points, but start looking at the equations like I did up here and see if you can figure out what your graph is going to do before you plot it. And then that kind of helps you check yourself, and if you ever see it in multiple choice questions, it makes it easier to answer. And that's it.